Good morning, girls. Today we are going to start a new topic called multi-threaded programming. So, what does it mean, and how a processor uh, executes multiple programs simultaneously, and what is the procedure? All these things that we are going to learn under this topic. So, see, here we see that Windows 95 or XP can execute several programs simultaneously. So, when we work with any operating system in general, we observe that we can do multiple tasks simultaneously. Like you can play songs in the background, and you can do some work. Like you write a document using MS Word, and simultaneously you can give print. Okay, so you can send a mail. All these things can be done simultaneously. But how they get executed, how what happens in the background, that is what we are going to learn in multi-threading. It is also called as multitasking. Um, in systems terminology, it is known as multi-threading. So, what is multi-threading? It is nothing but a concept where a program is divided into two or more sub-programs, processors, which can be implemented at the same time in parallel. So, one single program, it is only one single program or process, whatever you call it, it can be divided into two or more sub-programs or sub-processes, which are implemented simultaneously. See, remember one thing. Uh, Actually, you can't run two programs simultaneously. But how an illusion is created that the programs are are executed simultaneously, because the speed of the processor is it can complete a work in a blink of a eye, in the blink of an eye, or in the fraction of a second లో ఒక fraction లో అది ఒక పని కంప్లీట్ చేయగలదు. So when you give it a work and you try to assign some other work, uh, it will complete the first work very fast and it will sit idle. What it will do, it will sit idle. So what we are doing is, we don't want to put our processor idle or make it sit idle. So we are assigning multiple tasks to it, such that it will switch from one process to the other process. As soon as it finishes this, it jumps to this. It finishes this, it jumps to this. But we won't be able to identify that it is jumping between these processes. We think that the programs or processes are executing simultaneously. So this is what happens actually in the background. So this is to utilize the uh, what you say speed of our CPU to the max. We use this concept of multi-threading. So in general, we will try to understand what is actually multi-threading, or first we try to understand multitasking. See, when you have a lot of work at home, when your mother alone does the work, what happens? It will take a lot of time to her, and she's also burdened. Okay, so if the people in the house try to share her work. Let's see, if she is cooking, if someone does the cutting of the vegetables for her, she will do some other work in that meantime. So what happens automatically? The time which is taken to do the work comes down. And you can take one more example. So if you're cooking for a large number of people, like for a gathering or a marriage, you have to cut so many vegetables, and you will start you can't say that after cutting all the vegetables I will start cooking, because it will take time. So in order to give the person who, the cook, the vegetables, you will see some group of people, like 5 to 6 people, 7 people, who are designated the work of cutting the vegetables. So that whole process, their whole work is to cut the vegetables and give it to the person, or let them make them cook. So this is how the work is divided, so that the whole one person is not burdened with the whole work. doing work singly, in with single hand. So this is what we are trying to understand how it happens in a computer. So that is in general in our regular life or real life. So this is what we are inspired from the same thing. So how we can do or we can execute multiple programs and simultaneously in one single go. See, this is something similar to dividing a task into subtasks and assigning them to different people for execution independently and simultaneously. So they will be doing their works independently, they're not dependent on each other, and they will be doing them simultaneously so that the task will get executed in less amount of time. For example, see, one single person is cutting the vegetables and it might take half an hour to cut the vegetables for that person. So if we divide the task into three parts and we give them to three different people, so how much time will they take to complete the work? So obviously it will be completed in 10 minutes because each person is doing the work at a time, like 10 minutes, 10 minutes, 10 minutes, 30 minutes. So simultaneously they are doing it. So in 10 minutes as a whole, the whole task or work will be completed. So see, in most of the computers, there is only a single processor, and therefore the processor is doing only one thing at a time, right? So the processor switches between the processors so fast that it appears to human beings that all of them are being done simultaneously. This is what I have said. There is only one processor; it executes one process at a time, but it does the work so fast that we can't imagine, or if we sit or in the meantime we think what task we have to execute, it will do the work and sit idle. So to make the processor to or to which is effectively utilize the processor time, you will be um, giving it multiple tasks so that it will jump between these tasks and it looks like multitasking, or in systems terminology it is multi-threading. So this is how your single thread execution looks like. It starts with it has a beginning, and this is the execution, and finally it ends. I mean, the whole control is executes the program from first to end in one single uh, like go. I mean, it executes from first to last in one single step. I mean, complete. It is not switching. It is not going somewhere else. It is all the lines are executed in sequence and in only one single step. See, See, at any given point of time, there is only one statement under execution. So, at any given point of time, there will be only one uh, particular process or thread under execution. So, what is a thread actually? A thread is similar to a program that has a body and an end and executes commands sequentially. So, it is similar to a program. So, what a program has a beginning and an end, and finally in between those you'll have a body. So how the program executes, it will start with the beginning, continue with the execution, and finally it ends the program. So it will execute the commands sequentially. So all the main programs that we come across in our Java programs are single threaded programs. So see, every program will have at least one thread. So this is how a thread will execute. See, if you try to divide your program into multiple threads, this is how it looks like. So this is the main thread, and this is thread A, thread B, thread. This is only our what you say imagination, how it switches between the threads. So thread A, thread B, thread C. So the execution starts from the main thread. So first it will come to the thread A, it does the work here, and it jumps to thread B, it does here, and again thread C, it does the work here, and again it jumps back to thread A. Like that, it will be rotating between these three threads simultaneously, and uh, com- completes all the three threads at a time and returns back to the main threads. A unique property of Java is its support for multi-threading. So it is one unique feature which is supported in Java programming. So what is the use of this? It allows multiple flows of control in developing programs. So if you have multiple flows, this is one flow, this is one flow, this is one flow, you can create n number of threads. See, I have said you can any number of threads. The illusion is that the processor is doing them simultaneously, but actually the does them processor does them one at a time. We can't reach its speed. Because of the speed of the processor, it gives us this kind of picture. So each flow of control may be thought of as a separate tiny program known as a thread that runs into parallel to others as shown here in this figure. A program that contains multiple flows of control is called multi-threaded programming. So here, when you have multiple flows of control, so you have one flow, second, third, so you have multiple flows here. So it is called multi-threaded programming or multi-threaded program. A Java program with four threads and one main and three others. See, one main method and three other threads. This is how it looks like when multiple threads are created here in this program. See, once initiated by the main thread, the threads ABC run concurrently and share the resources jointly. So these three resources will be sharing the these three threads will be sharing the resources jointly. How do you share the resources? For example, the main difference is if you have um, a program, some address space is given to that program. So if you are a multi-programming and multi-threading, I'm telling you the difference between multi-programming and multi-threading. In multi-programming, what happens? You have multiple programs executed at a time. So each program is given its address space separately. So program 1, program 2, program 3, you have three different address spaces. If you take the same thing in a thread, one single program is divided into small threads, small processes. Here, all these three threads share the same address space because one program will have only one address space. So these three threads, whatever are created from this one program, will share the address space, the same address space. That comes under sharing of resources. And one more thing, as they share the same address space, the time to switch from one process to the other process will be very less. I mean, the overhead, the time or the overhead it takes to switch from one program to the other program is also very less because they are in the same space. So that is why reason they are also called as lightweight threads or lightweight processes. But it is not the case with multi-threaded programming. Multi-programming. Multi-programming, what happens? Every program has its own address space and the processor has to jump from one address space to the other address space. So it involves a little bit more overhead. So that is what is the disadvantage of multi-programming. So see, the ability of a language to support multiple threads is referred to as concurrency. What is this? Concurrency. So, like you can take the example of a joint family where all the people use the same resources. So here also, these all belong to one family or they are into the same address space or you can treat it as a house where they all use the same resources. So this is called concurrency. So threads in Java are subprograms of a main application program and share the same memory space. They are known as lightweight threads or lightweight processes. Okay, so the Java interpreter who handles the switching of control between the threads, the Java interpreter handles the switching of control between the threads in such a way that it appears they are running concurrently. It is only appearing to us like that they are running, but in the background they run one after the other in sequence. See here, the flow of execution is shared between the threads. So the processor which is executing is shared between these threads, which makes us feel that these three threads are getting executed simultaneously. So who is the thing, or who is person, not person, which part of the Java software handles this is Java interpreter. So what is the uses of multi-threaded programming? See, it enables programmers to do multiple things at a time. Okay, they can divide a long program into threads and execute them in parallel. Again, parallel in the sense concurrently. See, one can send tasks such as printing in the background and perform some other task in the foreground, like playing songs or doing some work or sending a mail. So this will improve the speed of your programs. So what is the main advantage of this multi-threaded programming is it improves the speed of your program. Nothing but the output of the program is given in a very small amount of time. So the more speed, the faster you will get the output. Excuse me. This is in the introduction about multi-threading, and these are the differences between multi-threading and multitasking. So please go through this difference, and let me know if you have any doubts in this table. And in the next class, I will start how to create a thread, how different it is from a regular program, and what are the methods you use, like uh, and how this switching of the control happens, what the states you have. So we will be discussing in the next. Take care. Bye.